So now I'm going to discuss on linear motion. Linear motion. So the word linear in this means straight line. That is a motion of a body or an object in a what? In a straight line. So a linear motion is defined as the what? As the motion of an object in a what? In a straight line. So that is to say, along the x-what axis. So in this, since physics, as well as physics, is an experimental science that deals with measurement. So there are some physical quantities that were used to describe linear motion. These physical quantities include the like of what? Some comes in two sets. The like of distance and displacement. These are the first set. Distance and what? And displacement. Distance here and displacement are different words entirely. Because displacement is the distance covered in a specified what direction. Now, for example, from this point to this point, for example, now here, point A to point B. The length here is the distance, is the distance. For example, x now is the distance. And all of that distance is always in meter. So, for example now, someone can decide to be moving or to be walking, for example, in a road without knowing where he is heading. So all those length that particular person is covering is just one distance. But when he covered a certain distance in a specified direction, knowing where he is heading, this is known as what? Displacement. So the difference between displacement and distance is that one is a vector quantity, the other is a what? It's a scalar what? Quantity. That is why, while defining displacement, we need to add what is the distance covered in a what? Specified or constant what? Direction. Remember, a displacement is the what? Is the distance covered in a specified or constant what? Direction. So this means that displacement here is a vector, while distance is a what? Is a scalar. Because a vector is defined in terms of direction, while a scalar is defined in terms of what? Magnitude only. This is both magnitude and direction. So from here, we can say that this both displacement and distance units is what? Is meter. The SI is what? Is m, that is meter. Then the second physical quantities a velocity, or I can write a speed and velocity. So speed and velocity are another two words that are used interchangeably. Speed is not velocity and velocity is not speed. But they have the same SI meter per second, but one is a vector and the other is also what is scalar. So speed in this case, I will say speed is the distance covered in a specific time. Meaning speed is the rate of change of distance with time. The rate of change of what distance with time. Mathematically, speed v equals what distance all over time. Because speed is related to distance, that is why speed is a what? Is a scalar quantity. Then for velocity, is the rate of change of what? Of displacement. Please remember this. Meaning speed here is distance over time, while velocity v is what? Is displacement over what? Over time. That is the velocity. I will use x for displacement and s for distance is x over what? Over t. So this means that the unit for both velocity and displacement is what? Is meter per second. This is what their SI unit. But remember, speed is a vector, whilst velocity is a vector, speed is a what? Is a scalar. So this is the difference between these two. So again, there is something that we call an average what? Velocity. Average what? Velocity. You call it what? The average velocity. Average velocity. Now, what is an average velocity along distance x? Now, for example, a body might cover a distance, for example, here from point A1 to point what? A2. Or for example, you can say that from Katsina to Kano, for example now. Let this be our distance x1, and there's another time he cover t1, and again here we have x2, and also what? The time he covers as what? As t2. So now, in this case, the slope of a graph, when graph is plotted, for example, between this, we now here is our what? Is our velocity here, for example, now our distance x, our time t, for example now. Someone can cover distance, we can figure out the slope here in this case. Now, for example, here we have x2, here we can have what? X1, here you can have our T1, here you can have our T2. Remember that slope is what? Change in displacement curve all over what? Change in time. meaning slope, because delta means change, change in x over what? Change in time. That to say, this according to we have something like this. Change in x means x2 minus x1 minus what? X1 all over what? T2 minus what? T1. This is our what? This is our average velocity. So average velocity average, AB here, pointing to x direction, is equal to what? Delta T, delta x over what? Delta T equal to what? X2 minus x1 over T2 minus T1.